The last approximation way we're going to look at is called Simpson's rule. This is also in your book. It starts on page 292 in your book. It's another formula to use. I will give you a program in class to work on using this, but I'm going to go ahead and give it to you by hand. The key with Simpson's rule is you can only use an even number of subintervals. It doesn't work if you have an odd number of subintervals. It's just the rule for Simpson. So let me give you the formula. If you have an integral that you're trying to approximate, then it equals b minus a over 3n. So this b minus a over n, remember that's your h. So that you could also write that as h over 3 times, we're going to write this similar to the trapezoidal rule, but it's a little bit different with its coefficients. We start out with 1, and then we have 4, and then 2, and then 4, and then 2, and so on and so forth. And then the one second from the end is 2, and the one next to the end has a 4, and then the last one is just 1. So remember, this is the same thing as h over 3. So it's the trapezoidal rule. We had 1 and then all 2's and then 1, and we divided by 2 here. Simpson's rule, we have 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, and then 1 again. So make sure you understand how the coefficients work for that. So let's try an example using Simpson's rule. Let's say we want to find the area under the curve from 0 to 3 of x squared plus 1. So, and we want 6 subintervals. So what we've got here is this parabola, and we're going from 0 to 3, and we want to know the area under this curve from 0 to 3. Of course, we can just integrate it and get an exact value, but we're going to go ahead and use Simpson's method to figure it out. So we need to figure out our x naughts, and so that we can figure out our x values, so we can figure out our y values. Instead of writing them all out like we did with the trapezoidal, I'm just going to write a table this time. And of course, with trapezoidal, you can do that as well. So we start at our a value, remember, and our n is going to give us what our h is, what we're adding between. So we take b minus a over n. So that means that we're adding 1/2 every time. So we just keep going until we get up to 3. So we plug in our values to our function so we can get the y values that go with it. So if we plug in 0, we get y is 1. If we plug in 1/2, we square that, we get 1/4 plus 1, so we get 5/4. 1 squared plus 1 is 2. 3/2 squared is 9/4. Plus 1 gives us 13/4. 2 squared is 4, plus 1 is 5. 5/2 squared is 25 over 4, plus 1 gives us 29 over 4. 3 squared is 9, plus 1 gives us 10. So we can now just plug this in, and we will get our answer. So we've got 3 minus 0 over 3 times 6. You can also do this as just the h over 3. I'll write that here since we erased it. All right. So you could say 1/2 divided by 3, which would give you the same answer. And then we plug in our values. 1 plus 4 times 5/4 plus 2 times 2 plus 4 times 13/4 plus 2 times 5 plus 4 times 29/4 plus 10. Remember our coefficients. 1, 4, 2, 4, 2, 4, 1. Add it all up, simplify it all down, and you get 12. That's your answer. Now you can also check it with numerical integration on your calculator, or you could check it. This would be x cubed over 3 plus x, evaluated from 0 to 3. 3 cubed is 27, divided by 3 is 9, plus 3 minus 0 minus 0, which gives you 12. And you can check it. I'm going to give you a program, as I said, to put in your calculator to do Simpson's rule, but you do need to know the formula and how to use it by hand, just in case you get in a situation where you're going to do that. When you're doing your homework, things like that, you need to try at least some of them by hand, as you should with the trapezoidal rule as well, and the rectangular approximation method. So those are our 3 approximation methods: rectangles, trapezoids, and Simpsons. Know those formulas, know how to use all of those, know what they mean and how they help us. Like I say, most of the time what we'll use this for is, in reality, is data processing, because when you have a chart of data, it's easier to use the individual pieces of data than have to first get an equation and then take the integral of that. So that's what we would use it for most of the time. Make sure you've read this section. By now you should have read all of section 5.5 and study the examples in the book so that you will be ready to ask questions in class.